I'm David Hicks with Revolution Golf Cars here in Augusta, Georgia. I'd like to talk to you guys a little bit about solenoids and explain the differences in these and explain to you exactly how they work. We get asked a lot, which solenoid do I need? Is this solenoid big enough? Do I need a pre-charge resistor? Do I need a diode on my solenoid? So we're going to address every bit of that here, and we're going to go over that and explain to you what each one of these little things does and how it works and how to make the right decision on which one you need for your application. So let's get started here. This is the factory replacement 48 volt solenoid for a club car, DS, precedent, it doesn't matter. Regular 48 volt stock controller, standard solenoid. You may see on your club car from the factory, it may not have these mounting tabs on the back of it. If you've got a newer cart, it may just slide down into a little slot. The slot mounted solenoid is what they used on the assembly line. The service replacement solenoid actually has these mounting tabs, and it does come with hardware if you order it from our site. That solenoid is only to be used with a stock controller or up to a 300 amp upgraded controller. In most cases is okay as long as you don't overwork the car a lot. This is the SW180. As you see, it is a little bit larger than the original club car solenoid. This one is a common solenoid for people to use with the upgrade packages like the Ultrax or the Navitas. Bigger controllers, the 440 or the 600 is, it's good for both. The Navitas AC kit on my personal car back here in the background, it's got this solenoid on it, and it's got the Navitas 600 amp controller on it, and it's held up perfectly fine. It's a good quality solenoid, and we've got it there on our site for you to purchase if you're interested in that one. This is probably our most popular solenoid currently. This is the MZJ 400 solenoid. It's got 3/8 inch studs as opposed to the 5/16 stud on the others. This is a heavy duty solenoid. It's rated for 400 amps consistent power and up to an 800 amp surge, which is not gonna happen. That's a lot of power. Most of your modern drive systems don't pull anything near that kind of power. So this is theoretically, it's overkill, but it works really well. It doesn't heat up because it's so overrated for most of the applications that we're putting this thing through. This is the little brother to the MZJ 400. This is the JCC 200 solenoid. Looks pretty much exactly like the MZJ 400. It's just smaller. This is a good solenoid for 400 amp controllers. It's got a 200 amp constant rating and a 400 amp surge. So up to a 400 amp controller, that's a really good solenoid for you. Okay, so now we're going to go over exactly what a solenoid does and how a solenoid works. So people often call and they tell me that they've got, such and such wire hooked to the positive side of the solenoid and another wire hooked to the negative side of the solenoid. There is no negative side of the solenoid. Think of the two large terminals as input and output rather than positive and negative. Technically, they're both going to be positive because one is positive power coming in, one is positive power coming out. The solenoid serves basically like a gate that opens and closes to allow energy into your controller when the controller is being used, when the golf car is being operated. When the golf car is sitting with the key switch off and the pedal released, the solenoid disengages or opens, breaking the connection between these two terminals. So I'd like to show you exactly how that works. We're going to set our meter to continuity. This is the continuity setting, also known as a diode test setting. So if your meter's got that on there, you'll put that meter on that setting, and you'll notice when you touch the two leads together, the meter beeps. Well, most meters beep, not all of them, but it will go to 000. The 000 on the screen indicates that there is no resistance at all between the black lead and the red lead. They're touching each other, so of course there's no resistance there. So what we're going to do here is we are going to use our eco battery and we are going to energize this solenoid, positive on one side and negative on the other. It does not matter which terminal you use for this, and we'll get on that more in a minute. So that solenoid just clicked on. I don't know if you could hear it in the video, but that solenoid clicked on. So now when we check it, we've got power. Well, continuity rather. We don't have any wiring hooked to it, so of course we don't have power, but we do have continuity, which means we have an internal connection between this side and this side of the solenoid. And you'll see here when we remove power, you'll hear the solenoid disengage. That we check it again, we don't have continuity here any longer. That means the solenoid is open. There is no connection between the two large terminals, and the solenoid is off. All four of these solenoids work the exact same way. Okay, so while we've still got our meter set on the continuity test setting, I want to talk to you a little bit about these diodes. So these two right here, they're the same. The only difference is one has the blade terminals on it and the other has the rings, and that's just because different solenoids require a different style pre-charge resistor. If you look at this SW180 right here, you'll see where it's got the blade terminals on it instead of these studs for the ring terminals. So I'm going to put this on this solenoid. I'm going to install it real quick, and we'll show you what it does. And we'll show you what to do when you're hooking it up, and we'll explain to you what not to do when you're hooking it up, because it is very crucial and can be very expensive if you do this wrong. So lots of controllers require you to run this diode on the solenoid. This is what we call a coil suppression diode. And what that means is it suppresses the coil of the solenoid when the solenoid receives power to the two small terminals to make it click. The solenoid coil voltage will be stamped on the side of the solenoid. This one is a 48 volt solenoid, as are all of these. That's because that's what we're using for testing over here, is this 51 volt eco battery, which runs a 48 volt system. If you've got a 36 volt solenoid, you need to make sure that your control voltage going to your solenoid coil is 36 volts. A 48 volt car typically has a 48 volt control voltage. There are exceptions, and we'll get to that in a minute, but the most important part here is to look at this diode, and you'll see that it has a silver stripe on one side and the other side is black. The silver stripe indicates positive. The black side without the silver stripe indicates negative. So this is going to go between these two small terminals just like this. And then your wiring for your car is going to go on these terminals as well. So it's going to be very important for you to understand the control circuit on your golf car when you hook this up, because certain different manufacturers of golf cars use different color wires for the positive versus the negative. Club Car IQ system, for instance, it uses a light blue colored wire for positive activation and a dark blue wire with a white stripe for negative activation. So as long as you put the light blue wire on the positive side of the diode and the dark blue wire with the white stripe on the negative side of the diode, you're good. However, if you invert those wires, you're going to cause a short, because the diode only flows one way. You're going to cause a short, and you're going to either blow out the logic in the controller that controls this solenoid that makes it click on and off on a SEPEX car or a AC system. On an IQ car, for instance, that's the SEPEX system, very common SEPEX system, as is the TXT48, the Yamaha Drive. All of those are SEPEX systems in which the controller logic controls the solenoid coil. In older series car, the controller doesn't control the solenoid. The solenoid is directly controlled by the micro switch in the foot feed, and that will turn the solenoid on and off. SEPEX cars also have a micro switch in the foot feed, but it relays a signal to the controller, which then turns the solenoid on. The micro switch is not directly wired to the solenoid on a SEPEX car. So if you take this diode off and you check it for continuity, you put the red lead on the positive and the black lead on the negative, and you look at the screen. Let me hold it on here better. Look at the screen on your meter. You don't get a reading. That's because the diode is blocking that flow of energy and it won't let it go through. That's what it's supposed to do. But when you reverse the leads, you should get a reading. Yep, approximately 500. That's what we want on these coil suppression diodes that we use. So that tells you that that diode is good. If the diode was bad, it would do that. It would beep when you checked it. That diode would be considered bad, and it would be creating a direct short in between these two terminals right here. So let's try this. I'm going to put this nut on here because we're about to have an arc. Put that nut on there. Put this nut on. So we're going to take the negative power from the battery pack and put it here on the negative side of the diode like it's supposed to be. And then we're going to take the positive and put it on the positive side of the diode like it's supposed to be. Solenoid clicks. Everything works like it's supposed to. That's because the diode is installed correctly. Now this diode can actually be flipped over and reversed, and the positive wire would move over to the positive side of the diode on the other side. The negative would go over here. As long as you flip the diode, you can flip the wires. It doesn't matter which terminals you use on the solenoid to turn it on and off with positive and negative. The orientation of the diode is all that matters. This post can be positive, this post can be positive, either one can be negative. Doesn't matter. It's all about the positioning of the diode. So let me show you what happens here. Let me put this fuse in the video so you can watch it. This is a fuse that we've got in here protecting our battery and our everything. So if you put the positive wire here on the negative side of the diode, hook this solenoid up wrong, and you put this negative side on the positive side of the diode, watch this. I don't know if you can see that in the video or not, but it just popped that fuse. That fuse is blown. We have a blown fuse because I have this wire to protect this circuit. These golf cars don't have a fuse on this circuit. So if you hook this solenoid up wrong, guess what? You just took out your controller, or you just took out your throttle micro on a series car. See, now that I've got it hooked up correctly, it's not working. That's because we've destroyed the circuit by hooking up this diode wrong on this solenoid. I don't know if you can see this fuse or not, but it is done. So as soon as we put a new fuse back in the fuse holder, solenoid clicks, everything's back to normal. If this fuse wasn't here, we would have had sparks and it would have been nasty. Okay, I want you guys to take a look at this SW180 because this is extremely confusing to a lot of people because they look here on the side and these are your small terminals for your solenoid coil that are used for activation. It looks like it's 4 terminals, but it's not. It's only 2. You've got an upper terminal here that goes all the way through the solenoid from one side to the other. And you've got a lower terminal that runs all the way through the solenoid from one side to the other. It's 2 terminals, not 4. The upper terminal is completely isolated from the lower terminal. And a lot of times, what people do is they will wire their golf car with their 2 solenoid activation wires like this. As you see, it blows the fuse because you're creating a direct short, just like we did earlier with the other system, with the other solenoid rather. So let's put this other fuse back in here. Put a good fuse back in it. We'll show you how this works. This one's done. Okay, when you put positive on top, negative on the bottom, solenoid clicks. Works great. Or positive on, if you invert them, positive on the bottom, negative on the top, it also clicks. Doesn't matter, like we talked about before, it doesn't matter which terminals you use to turn this thing on. The only thing that matters is the positioning of this diode. So that's the reason this solenoid right here has 4 terminals on it. It's done like this on purpose so you can put your diode on it and still have an open terminal to put your wires on. So that's how the diode goes on the SW180. So with the stripe pointing up, we put the positive here and the negative here. Solenoid clicks, solenoid works. That's the correct way to install that solenoid. As we talked about before, on a Club Car IQ system, light blue on top because it's positive, dark blue with white stripe on the bottom because it's negative. This is the factory solenoid for a club car 48 volt system. If you look real close, you may see this in the video, I don't know. There is actually a diode on this solenoid soldered between the two small terminals from the factory. This is a used solenoid, so it's a little crusty, but you get the idea. That's the reason it's marked. That's the reason it has this positive sticker here, is because the positive side of this diode is over here on this side. The negative side is over here. That's the reason that these two terminals are two different sizes, because Club Car does it that way. So when you're hooking up their wire harness, you can't screw it up because the small one won't fit over here and you can't hook it up wrong. So that's a good idea on their part for protecting their controllers against damage. Okay, so the last thing I'd like to talk about is a pre-charge resistor. The pre-charge resistor is not always necessary. It's always necessary on a series drive system. It is not always necessary on a SEPX drive system like the IQ system. It all depends on what controller you're using. The factory controller, the Curtis 1510, Curtis 1515, both use a pre-charge resistor on the factory solenoid in factory form. It does not matter which direction it's installed in. It can go either way. It's a resistor, it's not a diode. Power can flow through it this way or this way. So the purpose of the pre-charge resistor is to allow power to slowly and gradually pass through or around the solenoid while the solenoid is open or off. What this does is it pre-charges the capacitors in the controller and keeps them fully charged. This way, when you do get on the golf cart and you try to drive it and you press the accelerator and engage this solenoid, it is not a sudden rush of power into the controller, and this protects the capacitors in the controller and it makes it last longer. Again, not all controllers need this. The Navitas and Alltrax AC systems do not use this, nor do they use these diodes that we just talked about. So one of those systems, you don't have to worry about this stuff. Just act like they were never there. Take them off. You don't need them. But if you're hooking up factory controllers or any other aftermarket controllers that you're not sure about, please contact us and ask us, and we'll be glad to help. Okay, so this is the correct setup for an Alltrax XCT controller. We would run the solenoid with a diode. We don't need a pre-charge resistor. However, Alltrax will send what they call a regen diode in the package, and it looks a lot like this small diode. It's only it's larger, and it will go between the two large terminals on the solenoid. The striped side of the regen diode is going to go on the same terminal as the incoming battery power, or red wire, coming from the positive terminal of the battery. And the other side will go to the stud on the controller that runs to the B+ on the controller. So the correct setup for the Navitas TSX controller in series mode is going to be pre-charge resistor and diode. It needs them both if you run it in series mode. This is the same configuration if you're running an Alltrax SR controller. It needs both. If you're running a Navitas TSX controller on a SEPX mode, like an IQ car or a TXT48, you don't need either one. And the same thing can be said for the Navitas AC kit and the Alltrax AC kit. You don't need either one on the solenoid for either one of those two systems. So I'd like to talk about these pre-charge resistors a little bit further. This is a factory resistor for a 48 volt club car system. Different controllers and different voltages use a different ohm rating on the pre-charge resistor. The diodes are all the same, but the pre-charge resistor is different. So if you take your multimeter and set it on 2000 ohms, the 2K setting, and check this pre-charge resistor, this one actually shows 240, so that's pretty close to within range. A factory one is 250 or so. That's good. That pre-charge resistor is fine. I don't have any of the aftermarket ones here to show you guys, but for instance, on a 48 volt system with an aftermarket controller like the Alltrax or the Navitas that actually require a pre-charged resistor. You're looking for 470 ohms on those. So make sure you order the correct pre-charged resistor to use with that setup. And the 36 volt car, of course, it uses a different range pre-charge resistor as well. So there are different pre-charge resistor ranges for different 36 volt controllers. So it's always important to ask before you order, that way you don't get the wrong one. If you put the wrong one on it, you can damage the controller, and we don't want that. Hopefully this helped you guys, and hopefully now you understand how these things work a little bit better and when to and when not to use pre-charge resistors and diodes. If you've got any more questions, please feel free to reach out. info@revolutiongolfcars.com or 706-431-3917. Thank you.